Let us see this question. Suppose that we have this inductors, which is this value of 5 Henry, and our resistance R is 5 ohm, and we have source here. This EMF is a battery which is going to supply us 100 volt. Suppose that the switch has been in position 1 for very long time, and the steady current is 4 ampere, meaning that when the switch is position 1, the current flow in that circuit is 4 ampere, right? And then when at time t equal to 0, we're going to switch this one, go to the position number 2. So that means the current is going to flow from here, okay, in these directions here. Okay, now at this moment, at time t equal to 0, this is our initial conditions. Okay, that is, we have these initial conditions. Which is the I of 0 is equal to 4 ampere and E is equal to 0. Okay, so we have already been given these differential equations. Now find the current IT. Okay, so now we rewrite this down the differential equations. So E is equal to IR plus L DI over dt. Okay, so at time t equal to 0, which is we're going to turn the switch 1 to positions 2. At that time, then E will be equal to 0. So we're going to substitute here 0 equal to I R plus L di over dt. Okay, so in this case, here is I here. Okay, so now we can rewrite this. We have L di over dt is equal to minus IR. Okay, so now we can do the integrations of this part. We switch the I to the left side. Okay, we bring a constant to the right side over here. So we have di over I is equal to R divided by L. And then here we have negative over here. So now we're going to do the integrations on both sides. Here we have plus C. Okay, so integrations of currents inverse, we get ln of I. So this is equal to integration of constant, then we get minus R L and the times of T. Here is plus C. Okay, now we're going to take the exponential on both sides, then we get I is equal to, here we have exponentials minus R L T times exponential C, right? So now this can be rewrite into a single symbol. So this I could be equal to C exponential minus R divided by L of T. Okay, now we're going to substitute the initial condition that is given I of 0 is equal to 4. That means at time t equal to 0, I is equal to 4 ampere. Okay, so from this we can find what is the arbitrary constant C value. So I equal to 4. Here is C exponential minus R L times 0. So exponential minus 0 is 1. So we can find what is the C value. C is equal to 4. So we get our particular solution, which is the current I as a function of t is equal to 4 exponential minus R L of t. Now, what is R here? Okay, so we substitute these R values that we have is 5 ohm and L is 5 Henry. So we substitute over here for this. R is 5 ohm and our L is 5 Henry. So we substitute over here, then we get our I as a function of t is equal to 4 exponential minus t. So that is the particular solutions. Okay, so there's the answers for A. So now we see questions B. What is the current as t is go to infinity? So now we have the solution here, right? So now we're going to substitute this as time t goes to infinity. Then the value of I of t is equal to exponential minus. So t we substitute infinity. So in this case, 1 over infinity is 0, so that here we get 0 ampere. That means the currents will die out in this circuit. Okay, so that is the answer for this is 0 ampere as t go to infinity.